So I'll start off with the diagram. So first, the most important thing to do here is to annotate the diagram with all the information that we have. So small ring of mass 0.25 kg. So here's the ring, has a mass of 0.25 kg. So we are going to have a gravitational force of 0.25 g. Is fixed, is threaded on a fixed rough horizontal rod. The ring is pulled upwards by a light string. We can see that. Same vertical plane. Now it's a rough horizontal rod. Now, if I think about it, if the ring is being pulled to the right, then friction is going to oppose that. So we are going to have a frictional force acting in that direction. Let's call that mu r. Now it is held in place, so the rod is holding this ring up, so you're going to have your normal reaction, which I'm going to label R here. Okay, so this is your complete diagram. Now, what we do like to do is to any forces that are not vertical or horizontal, we can resolve in the various components. So I represent that with dotted lines here. So this force here is going to be 1.2 cos 40, and this is going to be 1.2 sine 40. I've got all my forces on here. Now I need to find the normal reaction. So if I call this part A, my question mark is here. Okay. So that is a vertical force. So my starting point is to say I'm going to resolve. Normally I'd write R arrow up, but just to make it clear that I'm resolving in a particular direction. You are resolving vertically because your normal reaction is a vertical force. Now, it's in limiting equilibrium, so forces are balanced in all directions. So vertically, your upward forces are going to equal your downward forces. So we have positive R. We've got positive 1.2 sine 40 equals, so these are your upward forces, they must equal your downward forces, and that is 0.25 g. And so from there we can work out our R, and let's do that. Oops. Menu 1. 0.25 times 9.8 minus 1.2 sine 40, and we get 1.7 newtons to 2 SF, and there is your normal reaction. Are we happy with that? Can you respond with a yes or a no? Or if you have any questions, let me know. All right, so that's part A done. I'm going to give you about 5 minutes hopefully to have a go at part B. We need to find the value of mu. Now mu is in the horizontal direction, so I'm going to resolve horizontally. I'm going to have mu r equals 1.2 cos 40. We worked out r earlier, so mu is going to equal 1.2 cos 40 over r, which was 1.7. But we are going to use the exact value. We're not going to use 1.7. That was a rounded value, wasn't it? Okay. So now, if I think about this, 1.2 cos 40 over what I stored in A, and we get 0.547, but because we've used G in our calculations, we are going to round that to 0.55. Okay, so, right, okay, so two forces P and Q act on a particle at point O. The force P has magnitude 15 newtons. So this is 15 newtons in this direction. What else do we know? Q, we can see, acts just horizontally. Has X newtons. We don't know what that is. The angle between P and Q is 150 degrees. We can see that as shown. The resultant of force P and Q is R. So the resultant of these two forces is R. So for example, if I was to put this arrow, let me just move that now. This would tell me where R ends up. So this is telling me that my force R the resultant would act in that direction there. Okay, that's how you figure out where your resultant, what direction that is acting in, and I'm going to call that R. Now we're given some more information. We are told that the angle between R and Q is 50 degrees. Okay, so we know that this angle here is 50 degrees. Okay, are we happy with that? Any questions there? Now, what do we need to figure out? Given that the angle between R and Q is 50, find the magnitude of R. Okay, how are we going to do that? Now, Q acts only horizontally. Actually, one thing I'm going to do is I'm going to resolve forces for P vertically and horizontally. So P is going to the left by that much, and it's going up by that much. If that was 150, this angle here is 30 degrees. So this would be 15 cos 30, and this would be 15 sine 30. And if I think about R would be going right by this much, and it's going up by this much. I might want to move. Oops. Sort of there, isn't it? So this becomes R cos 50, and this becomes R sine 50. Now, horizontally, Q has no impact. So what we can say is that the upward forces of P must be equal to the upward forces of R, because these are the only forces that are vertical. So 15 sine 30 must be the same as R sine 50. And from there we can work out R equals 15 sine 30 over R sine 50, not R sine 50, sine 50. And if we work that out, that's 7.5. Sine 30 is a half, so 15 times a half is 7.5, and then I've got sine 50 here. Close brackets, and we get R equals 9.79. And we haven't used gravity, so we can round that to 3SF. Okay, any questions there? Does that make sense? we're still resolving vertically and horizontally. That's got to be the key thing that you're doing here. And what we're realizing is horizontally, vertically, there was only one force. So that must be equal to the vertical component of R. And that's why we made those two components the same. Does that make sense? Can you let me know in the chat? So what we're saying is, because there's only one component, one vertical component, that's this vertical component of P, that must be equal to the only vertical component of R. The resultant of P and Q is R. Why can't we resolve horizontally? The reason we can't resolve horizontally is because Q's unknown. You would have had R's unknown, and you would have only had 15 cos 30. So you got two unknowns in one equation there, which we then wouldn't have been able to do. Does that make sense? P, we know the resultant of P and Q is R, so we're going to say P plus Q equals R. Are we happy with that? Now P was made up of two forces, as we could see. One, in the X direction, we had 15 or minus 15 cos 30. And in the Y direction, we had positive 15 sine 30. We had Q. Q is made up of just X movement to the right. So this is X and this is 0. And that equals, if we look at the resultant R, this was R cos 50 and this was R sine 50. Okay, so hopefully this has given you another method of thinking about resolving. And we can see the easier thing to do is look at the Y movements and make them equal to each other. Are we happy with that? Hopefully that erases all confusion. What are we going to do? So we've worked out what R is. We know what R is here, 9.79, and hopefully we're going to store that, and we've stored that already. Now to work out X, we could use the equation at the top, sort of become like a vectors problem, isn't it? Minus 15 cos 30 plus X equals R cos 50. Oops, R cos 50. And we know what R is, so there's only one unknown in this equation. So X should equal 9.79 cos 50 plus 15 cos 30. And we should work that out. So alpha A cos 50 plus 15 cos 30, and we get 19.28, which is fine really. Okay, we don't have to round this particularly to anything. We could have rounded it to 19.3 newtons. Got everything on there clearly now. What do we have? Package of mass 4 kg. So straight away, I'm going to have my gravitational pull of 4g. I'm going to split that into perpendicular to the plane and parallel to the plane. And this angle here is also 30. So we've got 4g cos 30, 4g sine 30. We are going to have our normal reaction, which acts perpendicular to the plane, and that is going to be R. What else do we have? A rough plane, isn't it? So there's friction involved here. Now, this 45 newtons can be broken into perpendicular to the plane, which would be acting in that direction, and parallel to the plane, acting in that direction. So just going to make that really clear. This is arrows pointing towards the plane, and this is parallel to the plane. So this here is going to be 45 cos 50, and this is going to become 45 sine 50. Now it's on a rough plane, so we also have friction acting. It says the package is in equilibrium on the point of moving up the plane. If it's on the point of moving up the plane, friction is opposing that, and therefore friction is going to be, if I color that in red maybe, is going to be acting in this direction here. And we're going to call that mu r. Okay. Are we happy with that? Any questions? So the key is to get the diagram sorted out properly. Now, once we have this, we can start thinking about the question. Now, magnitude of normal reaction. To work out friction, I'd have to work out normal reaction first anyway. So my first step is to resolve. Because R acts in perpendicular to the plane, I'm going to say resolve perpendicular to the plane. So in this case, we are going to resolve in that direction. Now, this object is in balance. Okay, it's in limiting equilibrium. So upward forces are going to equal downward forces perpendicular to the plane by that. That's what I mean. So we've got R, that's positive. This 45 sine 50 is negative because it's pointing perpendicular and down the thing. So minus 45 sine 50. And then you've got also acting perpendicular but in the opposite direction, 4g cos 30, so minus 4g cos 30, and that, because it's not accelerating, should be equal to 0. So from there we can work out that R equals 45 sine 50 plus 4g cos 30. And we can work that out. 45 sine 50 plus 4 times by 9.8 times by cos 30. So if we think about here's cos 30, we get 68.4 newtons, which we are going to round to 68 newtons. We're going to store this because we need to work out the coefficient of friction shortly. Right, okay. So we've done that. You have a go at the next bit, if you haven't already. So if we look at this diagram, what we can see is we need to work out the coefficient of friction. We need to work out mu. Now that is acting parallel to the plane. Here's the plane, and mu is acting parallel to the plane. So we are going to resolve parallel to the plane. So for part B, we're going to resolve parallel to the plane. And so we are going to resolve, maybe because mu r acts in that direction, I want to keep it positive. I'll resolve going in that direction and say that direction is the positive direction. Okay, now, what are we going to do next? So all the forces acting parallel to the plane now have to be accounted for. So we've got positive mu r. Now part of that 45 degrees was acting up the plane, so it's going to be negative. So we've got minus 45 cos 50. That was acting parallel to the plane. If we think about the weight of that object, that was broken into two components. That also has a parallel component, and that's 4g sine 30. But that is acting in the same direction as what we are going in. So we've got plus 4g sine 30 equals 0. That's what we should have had. Okay, now we know what r is. So we can use that now. So we can say mu times by 68.4 equals 45 cos 50 minus 4g sine 30. And so mu is going to equal 45 cos 50 minus 4g sine 30 all over 68.4. And so if we work that out, we've got 45 cos 50 minus 4 times by 9.8 times sine 30 over the answer that I just had. And we get 0.136, which we are going to round to 2SF, 0.14. Okay, there is our answer. So can you look at your working out and tell me where you have made the mistake? So it says, draw clearly all the forces on there. We'll come back to components. Now, you're going to have the gravitational force of 1.1 g. You're going to have your normal reaction, which is perpendicular to the plane, which we'll call r. The force acts in a vertical, the coefficient. The package is in the equilibrium and on the point of slipping down the plane. So if it's on the point of slipping down the plane, you're going to have a frictional force which is opposing the downward motion. So it's going to act parallel to the plane but going up the plane. And so we have got, and we're told that the coefficient is 0.5, so this is 0.5 r. We can do that straight away there. And these are all your forces. Now, this would have got you the marks. ideally, we don't just want to rely on this. We want to, because we know we're going to have to solve this, we want to break these into parallel and perpendicular to the plane. That is going to be going downwards here like so. And then you're going to go up the plane like so, and you end up there. All right, so again, identify what things you're now starting to realize what your mistakes are. Make a note of them. That's what's going to help you in the exam. And then if I think about this, we have got that. And so I'm going to say this here, because it's a horizontal force, this angle here is alpha. So this becomes P sine alpha, and this becomes P cos alpha. This is alpha. This is 1.1 G cos alpha, and this is 1.1 G sine alpha. Right, okay. This should be the starting point of all our calculations. Now find normal reaction, etc., etc. I've got two unknowns. I've got P and I've got R. So maybe I will resolve first perpendicular. So resolve perpendicular to the plane. And actually what we could do is, because it says tan alpha is 3/4, I'm going to draw a quick triangle. Here's alpha. This must be 3. This must be 4. This is 5. So sine alpha equals 3/5, and cos alpha equals 4/5. So if I resolve perpendicular to the plane now, where do we get up to? We have positive R going in that direction. We've got minus P sine alpha. I'm going to say minus 3/5P. And then we've got minus 1.1 G cos alpha is 4/5 times by 4/5. And there are no other vertical forces, so this equals 0 because it's in equilibrium. So that is equation number 1. So we can say R minus 3/5P equals 1.1 G times 4/5. Now if I resolve parallel, and I'm going to call that equation number 1, resolve parallel to the plane, and I should have said taking that direction as a positive direction. I'm going to say maybe taking that direction as a positive direction. We have got 0.5 R is positive. We have got plus P cos alpha is positive, but we've got the component of gravity minus 1.1 G times by 3/5 equals 0. And so we can say 0.5 R plus 4/5P equals 1.1 G times 3/5. Here is our equation 2. Are we happy with that? Does that make sense? Can you let me know in the chat or on your whiteboards? Did you get those equations? If not, what was the problem? Right, the key now is to start identifying where the problems, where are you dropping marks. So now I've got a pair of simultaneous equations. I don't want to work this out manually, so I'm going to go into menu, simultaneous, two unknowns. X I'll treat as R, so 1R minus 3 over 5 equals 1.1 times 9.8 times 0.8. And so that's equation number 1 typed in. Then we got 0.5R plus 0.8P equals 1.1 times 9.8 times 3 over 5, which is 0.6. So we get R equals 49 over 5, which is 9.8. So R equals 9.8, which is the right answer. And P equals 1.96, which is also the right answer.